Hi, I'm Neil Breakwell, designer of the Knights of England Dash Electronics, and in this video I'd like to give you an introduction to what our suite of electronics actually does. It's quite overwhelming, the number of features that we've built into this new suite of electronics, so we're going to break this video down into sections. We're going to have first of all a look at a basic overview of the fundamentals of the units and what the features are. And then later, in a later part, we'll look at the more advanced features. So let's start by having a look at the overall structure of the units. Now, at the moment, we offer the Season 3-4 Dash Electronics, which we've broken down into a number of modules. The compass module, which we call DM1, Dash Module number 1. The speedo board, which we call Dash Module number 2 or DM2. The voice box, which we call Dash Module number 3 or DM3. The tachometer board, Dash Module number 4 or DM4. And the power board, Dash Module number 5 or DM5. We've also developed our first Season 1-2 product, which is the speedometer. On the Season 1-2 dash, this comprises the entire left-hand side of the dash. In terms of the construction of the units then, they're all very similar, except maybe Dash Module number 3. This is a little bit different, so let's put that over to the side for a moment, and let's take a look at the other modules. All of the other modules comprise a precision-cut aluminum overlay, a main display circuit board, which houses all of the display components, a module that we call our GCM, Generic Control Module. We'll look at this individually in a later part of the video. But essentially this is the unit that we use for the control functions of all of the Dash electronic modules, and it's a standalone module. What else do we have? We also have a plexiglass rear panel, which is just to protect the electronics from any potential damage. So there's Dash Module number 1. You'll see also on each of these modules that we have a D-type connector and a series of 0.1 inch pitch terminal block connectors. Now, if any of you are familiar with our earlier suite of electronics, you'll notice that they just had these D-type connectors, and we've retained these on all of the new modules just for compatibility, so that if you have a vehicle which is already wired for the earlier versions of the electronics with the D-type connectors, they'll just plug straight in, they're pin-to-pin compatible. All of the functions that are provided on the D-type connectors are also available on the terminal block connectors, but the terminal block connectors provide some additional functionality which is only available on the GCM based modules, which we're actually going to call the Series 7 modules. So anything that's based on GCM, this little module here, is what we're going to call our Series 7 modules. That's the DM1 then, Dash Module number 1, the compass display. Dash Module number 2, very similar, the aluminum overlay. Actually, notice that these overlays are a little bit longer than the circuit boards themselves, and they have some vertical slots. The reason for that is just for mounting in the dashboard. These modules are actually held in by small brackets fabricated to the dash, which have horizontal slots in them. And those brackets with horizontal slots, combined with these overlays with vertical slots, allow a bit of adjustment in the positioning of the modules. Notice that there are no visible screw heads on our units because the overlays actually incorporate bonded M3 threaded standoffs, which the circuit board screws to. So there's no ugly screw heads on the front. Another thing to notice about our modules, which makes them, we think, unique is the fact that the LED display components are pushed actually through the apertures in the overlay. They're not sitting behind the overlay, as many replica products you'll find do that, but ours actually get pushed through the overlay, and the advantage of that is it aligns the LED display components very well, so they're perfectly well in line, they don't move out of position. We also, on the numeric displays, we put some red bezel on here to actually improve the contrast when viewing the modules in daylight. Okay, so that's dash module number 2, as we've said, similar construction, aluminum precision cut overlay with bonded in M3 threaded studs, a main display circuit board, a GCM, generic control module, D-type connectors, 0.1 inch pitch terminal block connectors, and a plexiglass overlay to protect it from any damage. Dash module number 4, again similar construction, aluminum overlay, LEDs pushed through the overlay. Notice actually that the LEDs that comprise the power arc on this tachometer display, they don't push through the overlay because they're just actually not completely shown, so that we get this arc to replicate what we saw on the TV. Display board, GCM, generic control module, D-type connector for compatibility with the earlier versions, terminal block connectors. You'll notice also that the GCMs have a little 6-way connector here. That is for reprogramming the GCM. As we develop the software, we'll post updates on the website, so you can just download those and use a what we call an ICSP, in-circuit serial programming tool, to reprogram the GCM to the latest version of software. So we can constantly update the software on any of these versions of the module that we purchase. Actually, we're going to make these products available because of the price of these overlays, which are fairly expensive. We're going to make them available with or without the overlays, just so that you can make your own if you wish to. Dash module number 5, which is the most right-hand module of the Season 3/4 Dash Electronics. Aluminum overlay, display circuit board, GCM, D-type connector, terminal block connectors. I think you're familiar with that construction now. Season 1/2, just the same kind of thing. Overlay, display circuit board, same GCM, D-type connector, terminal blocks, plexiglass rear panel. DM3, I said that was a little bit different. It is. It doesn't use the GCM. That's the main difference. But we say it doesn't use the GCM. In actual fact, it comprises a driver board and a display board. But the driver board on here is essentially a GCM with some extra stuff added on. There's the microcontroller, which is a microchip PIC device, which is exactly the same device that we use on all of these others. I think you can probably see that there. But this display board, in addition to this driver board, I said it is effectively a GCM. It's got the same PIC on it, it's got the same shift registers on it and everything, but it also has built in an audio preamp, so that you can just talk and the module will respond to the voice, the ambient audio signal. Again, it has a D-type connector, which is compatible with earlier versions, and terminal block connections. This module is actually built in two, so instead of a display board and a GCM like all the other modules, this has a display board and a driver board. The two just plug together with single inline sockets and headers. And as we've said, the driver board is effectively a GCM with a bit of extra stuff added on. So that's an overview of the basic structure of these modules physically. Let's take a look now at just an overview of the displays that are featured on these various modules. Let's start with the compass board, dash module number 1. This dash module number 1, it has these little plastic bezels on them. Now, these actually aren't available anymore, so we're trying to get hold of these or replicate them using 3D printing. But we may offer some of these modules without the bezels, simply because we can't get hold of them. We have on the compass board 4 bar gauges, 10 element bar gauges, each comprising individual LEDs, or we do offer these as well with bar gauge LEDs, but some people feel they look better with individual LEDs. The choice is yours. You can have them either with individual LEDs or with bar gauge arrays, and depending on what you choose, of course, you might need to use a different overlay, different version of the overlay. In addition to the 4 horizontal bar gauges, we have 4 LED light bars, which are shaped as arrowhead indicators representing north, south, east and west. And finally we have a little rectangular LED in the upper right corner here. We just use that as a diagnostic indicator so that any faults with the unit and this LED will flash. If there are no faults, that LED will be on continuously, indicating all is well. Dash module number 2 features a speedometer display, which is a 3-digit numeric section, a little indicator which just says MPH, and that indicator actually doubles to function as a diagnostic indicator on the power supply. So if the power supply to the module is good, that MPH indicator will illuminate continuously. If the voltage is out of range, like below 10 volts or above about 14 volts, then that indicator will flash. In addition to the numeric part of the display, we have a bar gauge comprising 14 individual LEDs. We have a 9-character odometer at the bottom. Obviously we only use 6 digits for the odometer, but this display here, to be TV authentic, we've given it 9 characters, and we double it as a message display, so we'll put messages on there at some points. And we also have, we'll look at this in a later video, something called show mode, where you can display a scrolling message and have all the displays indicate various patterns. That's something we'll look at in a later video. Okay, so we've looked at the speedometer numeric display, its associated MPH indicator, and by the way, if you're in Canada or Europe, you can replace that with an indicator that says kilometers per hour. We've looked at the speedometer bar gauge and numerics. We've looked at the message center stroke odometer display. We have another numeric display here, a 4-digit display, which by default is configured as a trip meter. But this can also be configured as a display to display various other analog inputs in numeric format. For example, fuel level in gallons or litres, temperature in Fahrenheit or centigrade, and other user-definable options. I did say that the features offered by this new suite of electronics can be quite bewildering, so let's just concentrate for the time being on the basic default configuration of these units. That's a trip meter, okay? We have 2 20-element bar gauges, the upper one which we generally use to represent temperature, the lower one which we use to represent fuel level. These 2 little LEDs here are again diagnostic LEDs indicating the state of the fuel input and the temperature input. If the fuel gets very low, or if it goes open circuit, the sender, then that will flash as a warning. Otherwise it will be on continuously. Similar with temperature, if the sender is open circuit or short circuit, or if the temperature gets excessively high, that will flash, otherwise it will be on continuously. These warnings, by the way, you'll notice one thing I didn't mention. All of these boards have an onboard speaker, a small speaker, to generate audio tones. There's a built-in audio tone generator on this GCM. And if we get any kind of warning or fault with the board, in addition to the corresponding LED flashing, you'll get a short warning beep to represent, hey, something's wrong, we need attention. So 2 bar gauges. By the way, you'll notice as well that the lettering on these overlays that I have here is not authentic to the TV. Now, we offer them with authentic TV lettering, but some people prefer lettering which corresponds to the actual functions offered by the units. So you'll see that on here, on the TV show, these bar gauges said something like signal and tuning. It's not signal and tuning, we use it for temperature and fuel. So we've marked them on these overlays, temperature and fuel. If you want TV authentic lettering, that's no problem, we offer that too. At the top here, we have another diagnostic LED, which we use to represent an overspeed. You can set that speed to anything you want and have this flash and sound the warning beep when you exceed any specific speed. A lot of these features, like the maximum speed, are something which we call user options. Again, we'll look at user options later. Set that to any value you want. So for example, set it at 90 miles per hour, and then that will flash and sound a beep when you get to 90 miles an hour. So these 3 individual yellow LEDs here are diagnostic LEDs, one for the speedo, one for the temperature, and one for the fuel level. And this one, this MPH indicator, is also a diagnostic indicator on the voltage supply level to the board. These 3 LEDs here we use to represent telltale indicators for the left turn, right turn, and high beam lights. These indicators here, these red-green pairs, are used to reflect the state of various high-switched inputs to the module, high-switched discrete inputs to the module. Again, these can be configured to anything you want, but the default are, this one represents the power is applied to the ECM, the engine control module. The second one represents the ECM engine control module is providing a high switched signal to the fuel pump relay. This one monitors the state of the fuel pump relay output, and this one monitors the state of the fuel pump relay fuse. So if there's any problem with the electric fuel pump, you can pick that up with which of these indicators is on. Green represents on and red represents off. This one is configured to the reverse lights. This one is by default connected to the fog lights, rear fog lights, and this one to the rear window defogger. Now we've divided the discrete inputs into 2 categories, primary indicators and secondary indicators. The reason for that is that we can put various parts of the display into show mode individually if those particular inputs aren't connected. So for example, if you decide not to hook up all these connections to the fuel pump relay, you can put all the secondary indicators into show mode whilst retaining the primary indicators in functional mode. The primary indicators are left turn, right turn, high beam and fog lights, because we feel that those are what are required, certainly in the UK, for getting through the annual test. So left, high beam, right, fog lights, fog lights, telltales for those, they're all primary indicators. So those can be switched into show mode or functional mode independently of the secondary indicators, these power level indicators, reverse lights and rear defog, which aren't actually essential to have indicators to get it through the test. Okay, that's quite a complex unit. There's a lot of stuff on there. Tacho board, engine RPM gauge. Again, a numeric component comprising a 3-digit numeric and a 32-element power arc, bar gauge display in the form of a power arc. an RPM times 100 indicator, which again is used as a diagnostic indicator on the power supply to the module, which will flash if the power supply is out of the 10 volts to 15 volt range, or will come on continuously if it's within that range and the power supply is considered good. It's interesting actually that the numeric part of the tachometer display is a 3-digit numeric, and this is RPM times 100. So if this third digit were to ever come on, that would be 100 RPM, 10,000 RPM. Obviously no automotive engine goes at that speed, and if you look at the TV display, the TV show, you'll see that that digit is never illuminated. So why they put a third digit there, I have no idea. But we decided to give an authentic display and provide the third digit. And we do sometimes indicate that when we're showing messages on there, but when you show in RPM, you only see those 2 digits. Actually, on the Season 1-2 tachometer display, I believe there's only a 2-digit display there. But we don't offer the Season 1-2 tacho board yet. That's coming soon. These horizontal gauges here, there are 6 7-element horizontal gauges. Now these can be configured again by user options as 6 individual 7-element bar gauges, or they can function as pairs and be configured as 3 14-element bar gauges, or you can have a combination. Either of the 2 pairs can be a single 14-element bar gauge, or can be operated as 2 7-element bar gauges. Again, we have a functional overlay here. We don't have the TV authentic lettering, but you can have that if you wish. But we have here the lettering which corresponds to the default functions built into the unit. So this top gauge, configured as a 14-element gauge, is, read it all the way across, engine oil pressure in PSI. The second gauge, inlet manifold vacuum in inches of mercury. The bottom gauge, battery volts in volts. We have the vacuum gauge by default operate from right to left because that's the way the vacuum gauges are generally displayed. Any of these gauges can operate left to right or right to left, whether you're in 14-element display or 2 times 7-element display, and also each display can be configured as a continuous bar gauge or a moving point where only one LED is illuminated. Dash module number 5, DM5. A small 4-digit numeric display, which by default we use to display battery volts. That's why on the functional lettering we've got the battery volts displayed. I think on the TV show it said something like program number on there. Again, that can be configured to display a numeric display of analog inputs if you so wish, but by default it's battery volts. 3 individual, oh yes, by the way, these are diagnostic LEDs as well. These associated LEDs here are diagnostic LEDs on the bar gauges, flashing to mean a fault and continuously on to mean no fault. If you have one of these bar gauges configured as a 14-element display and there's a fault, both of the LEDs will flash. If they're configured as individual 7-element displays, only the LED corresponding to the gauge with the function that has the fault will flash. So similar bar gauges on DM5. The upper one we use by default to represent battery voltage. The second one, throttle position. So that's just the position of your gas pedal in percent. And air temperature on the lower gauge. We just fit an aftermarket air temperature sender and connect it to there. Any fault on any of these inputs, again we have a diagnostic LED which will flash. The bottom half of the dash module number 5 comprises 4 large indicators, or rather pairs of indicators. These work as a pair, labelled power, normal, auto and pursuit. Now the normal, auto and pursuit pairs are again just connected to ground switched inputs, and they can be connected to anything that you like. we produce a little module which switches between normal and auto indications when you put your foot hard to the floor. I'm sorry, when you when it switches between normal and pursuit, or auto and pursuit, when you put your foot hard to the floor, or switches between normal and auto when you use the auto cruise, when you use the cruise control of the car. These are actually generally hooked up in parallel with the normal, auto and pursuit indications on DM3, these lower three indicators. Now this power pair here is used in a similar way to the MPH or the RPM indicators on DM2 and DM4, in that if the power supply is within the range of about 10 volts to 14 volts, this pair will illuminate continuously, whereas if the voltage supplied to the module goes outside of that range, it will flash and indicate a fault, associated with a momentary audio beep. Four pairs of green-red indicators which are connected to ground-switched discrete inputs. This one, by default, we connect to the check engine indicator. This one indicates the brake hydraulic fluid level, the park neutral position on your gear selector, and this one, which we use to represent the state of a lighting changeover switch that we use on these cars, because in the UK it's essential to have amber coloured rear turn signals, whereas in the US we tend to flash the brake lights. But we have a little relay box that we can fit to switch that lighting over, so that you can have the authentic brake lights flashing, or you can have the UK legal system. And when we change that over, we represent the state of that selection on this indicator here. These indicators can actually be used to reflect the state of any ground switched discrete inputs. So that is essentially DM5. Let's have a look at the fifth, but Dash module number 3 module on the Season 3/4 Dash Electronics, and you know that it has the three vertical strips of 20 LEDs, which give the familiar kit or car, if you wish, display pattern. We can use yellow LED arrays here and put car configuration if you wish. And it has these other pairs of indicators which come on as the power-up sequence. We don't have the legends on there yet, the transfers, so this one's just requiring finishing off. Let's finally take a look at the Season 1/2 speedometer board then, and when we've done this we'll have another section of the video in which we'll look at actually applying power to the boards and familiarising ourselves with the various displays. The best way I can describe the displays on Season 1/2 speedometer board is probably by comparison with the Season 3/4 DM2 board. Again, we have, in the same way that we have a 3-digit numeric speedometer, we have a 3-digit numeric speedometer. We have an MPH indicator, which again I haven't fitted the legends on yet, and a numeric, and a bar gauge component of the speedometer as well. On the Season 3/4 speedometer bar gauge display, it's a 14-element bar array. On the Season 1/2, it's a 20-element display. The Season 3/4 module has a 9-character 7-segment display, and for authenticity with the earlier version of the Dash, we have here a 10-character display, and these individual components, to be authentic to the original, are 14-segment alphanumeric displays. So although we don't use the vacuum fluorescent displays which were on the original show, which are very difficult to get hold of and also very difficult to drive electronically, we use LED displays which give the same appearance, and they're much easier to maintain. So we have the 14-character alphanumeric display, which represents the odometer, and also is used as a a message center. We have a 4-character 7-segment display here, which is exactly functionally equivalent to the 4-digit numeric display here. This displays by default a trip meter, and as we've said, we can configure these to display numeric values of various analog inputs, but by default a trip meter. A bar gauge, a 16-element bar gauge here, which functions in a very similar way in terms of how we can configure it to the bar gauges on DM4. In other words, we can use this bar gauge as a single 16-element bar gauge, or as 2 independent 8-element bar gauges. These LEDs immediately above it are indicating diagnostic state of this bar gauge. Now, by default on the Season 1-2 board, we do configure these as 2 8-element bar gauges. We use the left-hand 8 elements to represent temperature, engine temperature, and the right-hand 8 elements to represent the fuel quantity. So the left-hand side of this gauge is equivalent to the upper gauge on here. The right-hand side of this gauge is equivalent to the lower gauge on here. In terms of the diagnostic LEDs, if this bar gauge is configured as a single 16-element display, then the center LED has the functionality of the diagnostic indicator for this gauge, while the outer two are on continuously regardless. However, if we configure this bar gauge as 2 8-element gauges, then the center element will come on continuously regardless, and the left LED will represent the diagnostic state of the left-hand side of the gauge, while the right LED will represent the diagnostic state of the right-hand side of the gauge. These 3 LEDs here are telltales equivalent to these: left turn, high beam, and right turn. These secondary indicators, 1, 2, 3, 4, engine ECM power, is represented by the state of this horizontal gauge, which will say system ready. This one, the fuel pump relay drive, is equivalent to this lower indicator, which marks on the TV authentic lettering as guidance. This one and this one correspond to this one and this one. Reverse lights corresponds to this one, and these last 2, fog lights, correspond to the center one there, and rear defog corresponds to the right hand one. This left hand one is used as a diagnostic state on the state of the speedo. So this one here, left hand one, is equivalent to the speedo diagnostic indicator on there. And then these last 2, as we've said, those 2 and those 1, 2, 3 are those 1, 2, 3, and those 2 equivalent to these. Okay, so I don't think we've missed anything. Again, we have filter over here to improve the contrast, and I think that is probably enough for the first section of this video, which has given hopefully an idea of the overall construction of these modules and the displays that are available. So in the next section we're going to take a look at powering up each of the modules and having a look at the displays. As we say, we'll just look at the default configuration for now, because otherwise it will get a bit overwhelming. One thing I will mention though before we finish this section of the video is that every one of these modules offers 4 different operating modes. 2 modes which you'll generally use are normal running mode, which are the fully functional mode for driving, and show mode or demo mode, which is a mode that you can put the units into, for example at car shows, to give a more active and interesting display, generating patterns, user-definable patterns, and moving the numerics around just to make the display look interesting. And as we've said, we can, in normal running mode, you can select individual sections of the display to be functional and individual sections of the display to be in show mode. So for example, as we mentioned earlier about the primary and secondary indicator categories, we could put the secondary indicators into show mode if we didn't want to hook them up, whilst retaining the primary indicators in normal functional mode. And on the Season 1-2 speedometer board, the primary indicators are left and right turn repeaters, turn telltales, high beam telltale, and what else? The fog lights, which is that one there, I think. Okay. The other operating modes that each of these modules has, apart from normal running mode and show mode, are a couple of diagnostic modes. Output test mode, which enables the module to be to exercise, to individually switch on and off every display element, every element of every display, which includes every segment of every numeric, every segment of every alphanumeric. It'll go through and individually switch on and off each element so that you can make sure everything is working. It will also go through a sequence putting different tones onto the audio speaker. By the way, those audio speakers, in order to use the onboard audio speaker, we put a link in the edge connector in the corresponding position. If we remove that link, it's possible to use an external speaker for any of the modules as well. So normal running mode, show mode, output test mode. The final mode that we have available is input test mode, which is a mode that enables all of the inputs, including those like control functions that aren't normally be displayed, to be displayed on the actual unit, so that we can test the state of each input. It also enables us to read the state of each analog input as a hexadecimal number, so we can see what value is coming from the analog to digital converter on each of the analog inputs. And that's useful in calibrating the unit, so we can find out exactly what value is coming from each sensor and thus set the calibrations. I did say this was going to be the basic video, so I won't say any more about that now. We'll look at all that kind of good stuff in a later part of the video. Okay, let's close that section, and when you're ready, move on to the next section, which will talk about putting power onto the units and actually seeing these modules light up and what the displays look like.